What is electron beam welding? Electron beam welding is a highly specialized welding process that uses a focus beam of high-velocity electrons to join two metal parts together. It is a type of fusion welding that produces a very precise and clean weld, making it ideal for applications where high-quality welds are required. Electron beam welding is commonly used in the aerospace, automotive, medical, and electronics industries, among others. In this article, we will explore the world of electron beam welding, including how it works, its advantages and disadvantages, and its various applications. Whether you're a welding professional or simply interested in learning more about this fascinating technology, read on to discover everything you need to know about electron beam welding. 2. How electron beam welding works. Electron beam welding is a process that involves the use of high-energy electrons to join two metal parts together. The process works by generating a beam of electrons that are accelerated to very high speeds using an electron gun. The electrons are then focused onto the workpiece using magnetic lenses, creating a concentrated and intense heat source. The heat generated by the electron beam causes the metal to melt and fuse together, forming a strong and durable bond. The process is carried out in a vacuum chamber to prevent any interference from air molecules, which could scatter the electrons and reduce the effectiveness of the weld. Electron beam welding can be performed with either a stationary or a moving beam. In the stationary mode, the workpiece is moved under the fixed electron beam, while in the moving mode, the beam is moved across the workpiece. The process requires a high level of precision and control, as even small variations in the beam's intensity or focus can affect the quality of the weld. To ensure accuracy, electron beam welding machines are equipped with sophisticated control systems that monitor and adjust the beam's parameters in real time. Overall, electron beam welding is a highly effective process for joining metals with high melting points, such as titanium, nickel alloys, and stainless steel. Its ability to produce strong, precise, and defect-free welds makes it a popular choice in industries such as aerospace, automotive, and medical device manufacturing. 3. Advantages and disadvantages of electron beam welding. Electron beam welding has several advantages over other welding techniques. One of the most significant benefits is its ability to produce high-quality welds with minimal distortion. This is because the process uses a highly focused beam of electrons, which can be precisely controlled to create a narrow and deep weld that penetrates the material without affecting its surrounding areas. Another advantage of electron beam welding is its speed. The process is much faster than traditional welding methods, which means that it can be used to complete projects in less time and at lower cost. Additionally, the process can be automated, which further increases efficiency and reduces labor costs. However, there are also some disadvantages to electron beam welding. One of the biggest drawbacks is the high cost of equipment and maintenance. The specialized equipment required for this process can be expensive, and the process itself requires a vacuum environment, which adds to the complexity and cost of the setup. Another disadvantage of electron beam welding is its limited applicability. While it is an excellent choice for certain materials and applications, it may not be suitable for others. For example, the process is not recommended for materials that are highly reflective or conductive, as these can interfere with the electron beam and reduce its effectiveness. Despite these limitations, electron beam welding remains a popular choice for many industries due to its unique advantages and capabilities. By understanding the benefits and drawbacks of this process, manufacturers can determine whether it is the right choice for their specific needs. 4. Applications of electron beam welding. Electron beam welding has a wide range of applications across various industries. One of the most significant applications is in aerospace and defense, where it is used to join critical components such as turbine blades, rocket engine nozzles, and fuel tanks. The high precision and accuracy of electron beam welding make it ideal for these applications. Another area where electron beam welding finds extensive use is in the medical industry. It is used to manufacture surgical instruments, implants, and other medical devices that require high precision and biocompatibility. Electron beam welding ensures that the final product is free from any defects or impurities that could cause harm to patients. The automotive industry also uses electron beam welding to produce high-quality parts such as engine blocks, transmission components, and exhaust systems. The process allows manufacturers to create complex shapes and designs that would be difficult to achieve using traditional welding methods. Electron beam welding is also used in the electronics industry to join small components such as wires and connectors. The process is highly precise and can be automated, making it ideal for mass production of electronic devices. Finally, the energy industry also uses electron beam welding to manufacture components for nuclear reactors, turbines, and other power generation equipment. The process ensures that the components are strong, durable, and able to withstand extreme temperatures and pressures. Overall, electron beam welding has a wide range of applications across various industries, and its versatility and precision make it an attractive option for manufacturers looking to produce high-quality components.